Teleportation problems and 10 characteristics. Transport weapons, drugs, stealing people, stolen goods, money, gold. The dark side of teleportation. Replacing many services, working places, and money-making opportunities, just by a transfer in second between two countries being at 25 kilometers distance. Teleportation, the ability to instantly travel from one location to another, has fascinated people for ages. In science fiction and theoretical physics, teleportation is often depicted as a transformative power that could revolutionize transportation, communication, and even our understanding of space and time. Here are 10 defining characteristics of teleportation. 1. Instantaneous travel. Teleportation, in its ideal form, enables immediate travel between 2 points without any time delay. Unlike conventional travel methods, which are constrained by time and speed limits, teleportation eliminates these barriers, allowing instant transportation from one location to another. This characteristic has profound implications, as it redefines how quickly individuals or objects can move, fundamentally changing travel and logistics. 2. Energy-intensive process. Teleportation is theorized to require enormous amounts of energy. Theoretically, to move matter instantaneously, teleportation would need a large energy source to overcome spatial distance, disassemble matter, and reassemble it at the destination. In a scientific sense, manipulating or transmitting the particles that make up physical bodies or objects would require incredible energy precision, making it a potentially costly process. 3. Matter manipulation and reconstruction. One of teleportation's unique aspects is its ability to disassemble and reassemble matter. This process involves breaking down an object or person into their atomic or subatomic components, transporting this information across space, and reconstructing the entity exactly as it was. This precision in reassembly is crucial for maintaining the integrity of the object or person. 4. Instantaneous communication potential. Teleportation could revolutionize communication, allowing instant exchanges of information or material between locations without the need for cables, satellites, or signals. This form of communication could operate without delays or signal interference, making real-time interaction possible across vast distances. Teleportation, if mastered, might even open the door to instantaneous data transfer, providing seamless, instant connectivity on a global scale. 5. Complex quantum mechanics. Teleportation is often associated with the principles of quantum mechanics, specifically quantum entanglement, where two particles can be linked regardless of distance. Quantum teleportation, though different from physical teleportation, involves transmitting the state of a particle to another without physical movement. The link between teleportation and quantum mechanics adds layers of complexity, emphasizing the theoretical and experimental nature of teleportation. 6. Spatial freedom and accessibility. Teleportation would enable unparalleled access to remote or otherwise unreachable locations. Traveling across dangerous terrains, extreme weather, or vast distances, such as space travel, would become possible and convenient. Teleportation could even transform emergency responses by allowing quick travel to critical areas, improving access, and potentially saving lives in remote or disaster-stricken areas. 7. Reduction of physical travel infrastructure. With teleportation, conventional travel infrastructure like roads, railways, airports, and seaports would become redundant. This shift would significantly impact the need for transportation systems, freeing up resources and reducing environmental impacts associated with transportation. The potential for less pollution, noise, and urban congestion aligns teleportation with sustainable development goals. 8. Physical and ethical risks. Teleportation, particularly of living beings, raises serious ethical and physical questions. The process of disassembling and reconstructing matter, especially of conscious beings, brings up concerns about safety and potential harm. Questions arise about whether a person transported this way would still be the same individual, sparking ethical debates over identity and the nature of consciousness. 9. Economic and social transformations. Teleportation would bring transformative changes to economies and societies. Industries reliant on transportation such as logistics, shipping, and tourism could face major shifts or even obsolescence, while new industries centered around teleportation could emerge. Social dynamics would also change, as geographic barriers would no longer limit relationships, education, or work, possibly reshaping community structures and cultural exchanges. 10. Possibility of teleportation for only specific particles. Currently, teleportation as imagined in science fiction is purely theoretical, but quantum teleportation of particles has been demonstrated in controlled laboratory conditions. This form of teleportation, however, applies only to information about particle states, not the particles themselves. This distinction shows that while teleportation is theoretically possible at the quantum level, achieving it with complex objects or humans remains a significant scientific challenge. Conclusion. Teleportation's characteristics reveal an array of transformative possibilities and challenges. The energy demands, ethical considerations, and the science of particle manipulation make it a fascinating yet complex idea. While quantum teleportation has demonstrated limited feasibility, the full realization of teleportation as imagined remains an inspiring, albeit distant, vision. If teleportation becomes a reality, it would not only change how we travel but also reshape society, economics, and the understanding of reality itself.